In this video, I'm going to show you how to solve linear inequalities. There are four types of inequalities: less than or equal, greater than, and greater than or equal. Here are a couple examples. First of all, 1 is less than 2, because 1 comes to the left of 2 on the number line. Likewise, 3 is less than 5, -1 is less than 10, and -7 is less than -4. But it's not true that 2 is less than 2, because 2 and 2 are equal. Neither of them is less than or bigger than the other. Likewise, it's not true that -3 is less than -3, because again, these are equal. With less than or equal, however, we allow 2 is less than or equal to 2, and -3 is less than or equal to 3. The reason we allow this is because of the or equal part, which is indicated by the line under the less than sign. And we've still got our original less than statements. Those also hold for less than or equal to. 1 is less than or equal to 2, 3 is less than or equal to 5, and -1 is less than or equal to 10, and -7 is less than or equal to -4. So less than or equal is just less than and also allowing equality. With greater than, here are a few examples. 2 is greater than 1, 7 is greater than 4, -3 is greater than -5. It's pretty much less than, just flip the other way. 1 is less than 2, so 2 is greater than 1. 4 is less than 7, so 7 is greater than 4. -5 is less than -3, so -3 is greater than -5. But again, we don't have 2 is greater than 2, and we don't have -3 is greater than -3, because greater than does not permit equality. One number has to be bigger than the other, so they can't be the same. However, with greater than or equal, we do allow equality. So we've got 2 is greater than or equal to 2, and -3 is greater than or equal to -3. And we've also got our original greater than statements. 2 is greater than or equal to 1, 7 is greater than or equal to 4, and -3 is greater than or equal to -5. So again, greater than or equal to is just the same as greater than, but allowing equality. So how do we solve an equation which has an inequality instead of an equal sign? Well, we solve it pretty much just like we'd solve any other equation. We can perform algebraic operations to isolate x on one side. So to start off, we can subtract 5 from both sides to cancel out that +5. And then, so the +5 cancels, and we've got just 3x is greater than -4 minus 5 is -9. Okay, and now to isolate x, we need to get rid of the 3 in front of it, so we can divide by 3. Then these 3's cancel, and we've just got x is greater than -3. There we have it. There's our solution. Any number for x that's greater than -3, like -2 or -1 or 0, will work in this equation. We can test our answer by noticing that 0 is greater than -3, so 0 should work in this equation. Let's try it. 3 times 0 plus 5 is greater than -4. So 3 times 0, that's just 0, so that cancels, and we've got 5 is greater than -4. That works out, so it makes sense that this is our solution. Here's another example, which is pretty similar to the previous example, but something a little bit different is going to happen later on as we solve it. So we're going to start off in the same way. We want to isolate x, so let's get rid of that 1. Let's subtract off 1 on both sides. And the 1 minus 1 cancels with that positive 1, so we've just got -4x is less than or equal to 9 minus 1, which is 8. And now we want to get x alone, so we can divide by negative 4 to cancel that negative 4. And then we have that negative 4 cancels with that negative 4, and we've got just x. And then on this side, we've got 8 divided by negative 4, which is negative 2. And now the catch here is that because we divided by a negative number, we have to flip the sign of the inequality. So because we divided by a number which is negative, we have to flip that sign. Originally it's less than or equal to, now we have to flip it to greater than or equal to. So this is the solution to the inequality. And that might seem strange, but we really do have to flip the sign in order for the solution to be true. We can test out 0 is greater than or equal to negative 2, and if we plug in 0 in the equation, we get negative 4 times 0 plus 1 is less than 9. So this cancels, and we've just got 1 is less than 9. So this is the true solution. Numbers which are greater than or equal to negative 2 work here. And we'll talk about why we flip the sign in just a moment. Before we talk about why we have to flip the sign, let's do a few examples to highlight when we have to flip the sign. So when we multiply or divide by a negative quantity, we always flip the sign. So for example, here we need to divide by negative 2 on both sides to get that x alone. And then we have on this side x, and then on this side we've got 16 divided by negative 2, which is negative 8. And then because we divided by a negative number, we have to flip that sign. Instead of a greater than, it becomes a less than. Okay, now for the next problem, 3x is less than 9. We have to divide by 3. And then the 3's cancel out here, and we've just got x, and 9 divided by 3 is just 3. And we didn't divide by a negative, we divided by positive numbers. And since we didn't divide by a negative, we don't flip the sign. So it stays as a negative. Here we've got negative of x over 5 is less than or equal to 2. And to cancel out this negative over 5, we have to multiply by negative 5 on both sides. So let's do that. And then the multiplied by negative 5 will cancel the negative over 5, and we just have x on this side. And then 2 times negative 5 is just negative 10. And because we multiplied by a negative number, we have to flip the sign. So x is greater than or equal to 10. And our last example, x over 4 is greater than or equal to 3. To cancel out that over 4, we can multiply by 4 on both sides. Then the times 4 cancels with the divided by 4. And then we just have x on this side. And we have 3 times 4 is 12. And since we didn't divide or multiply by a negative number, our number here, 4, is positive, we don't flip the sign. So it stays x is greater than or equal to 12. Now let's talk about why this rule is true. We know how to use this rule, but why? Why do we even have to use it in the first place? So I think the best way to explain why this rule is necessary is to start off with a simple inequality. 1 is less than 2. And now let's see what happens when we multiply by a negative number, say negative 1, just to keep things simple. When we multiply by negative 1, on the left-hand side we have 1 times negative 1, which is just negative 1. And on the right-hand side we have 2 times negative 1 is negative 2. And if we don't flip the sign, then we have negative 1 is less than negative 2. But that's not true. -1 is greater than -2. In order to fix this result, we have to flip the sign of that inequality. We have to change it to -1 is greater than -2, so that it remains true. We're going to end by solving a more complicated inequality, which has x on both sides of the inequality. And we're going to do this the same way as usual. We're going to try to isolate x on one side of the inequality. So in order to do that, let's start off by, let's say we're going to isolate x on the left-hand side, and we'll start off by subtracting this 5 over to the other side. So -5 on both sides. And we do that, and this cancels here, so we've just got 1/3 x is greater than x, and then 2 minus 5 is -3. Okay, now let's get x on the left-hand side of the equation. So let's subtract x from both sides to cancel off that x on the right-hand side. And then we've got, we'll just keep this as 1/3 x minus x, and we'll simplify it in the next step. So that is greater than -3 on the right-hand side. Okay, now to simplify this, we can write it as 1/3 x minus 1x is less than -3. So 1/3 x minus 3/3 x is greater than -3, because 3/3 is just an equivalent representation of 1. And then we can go ahead and subtract the fractions. So -2/3 x is greater than -3. Awesome. So now we just have to get this -2/3 off of the x. And to start off, let's take care of that negative sign. So let's just multiply both sides by -1. So the left-hand side, we multiply by -1, that cancels the negative sign, and then we've just got 2/3 x, and then on the right-hand side, we've got -3 times -1, the negatives cancel, and we've just got 3. But remember, since we multiplied by a negative, we have to flip that sign. So this becomes 2/3 x is less than 3. And now we can proceed normally to solve x. Let's multiply by 3 on both sides to cancel out that 3 in the denominator. So times 3 times 3, and the 3 cancels that 3 in the denominator, and we've just got 2x is less than 3 times 3 is 9. And to finish it off, to get this 2 off of the x, we'll divide by 2 on both sides. And then we get 2x divided by 2, the 2's cancel, and we've just got x is less than 9/2. And there we go. There's our solution. We can check our solution by thinking, well, 0 is less than 9/2, because 9/2 is a positive, so 0 has to be to the left of it. And if we plug in 0, that should work in our equation. 1/3 times 0 plus 5 is greater than 0 plus 2. Well, 1/3 times 0 is just 0, and so we've got 5, and then 0 plus 2 is just 2. So yeah, checks out. So our solution seems valid. In the future, we'll learn how to extend these techniques to solve compound inequalities, which involves solving two inequalities simultaneously.